Welcome to Mr. Chalk's Revision Tips. In this video, we will look at
magnets, magnetic fields, and plotting fields. So a magnetic domain is the region in which the magnetic field of atoms are grouped together and aligned. So in an experiment, you can show that the magnetic domains are indicated by the arrows that show which way the magnets are facing. So you can think of the magnetic domains as miniature little magnets within the material. So if we look at these two diagrams, we can see there in a magnetic material, all of the norths are facing one way, all of the souths are facing one way, whereas in a non-magnetic material, they're all kind of jumbled up. So if we're explaining this statement, so a magnet or a magnetic field is a non-contact force. So this is correct because the magnets are not touching, however they still experience forces that are exerted from other magnets. A permanent magnet produces its own magnetic field. An induced magnet is a material that becomes magnetic when it is placed in a magnetic field. Induced magnetism always causes a force of attraction. When removed from the magnetic field, however, an induced magnet loses most, if not all, of its magnetism quickly. So if permanent magnets are repeatedly knocked, the strength of the magnetic field is reduced. Magnets are made from magnetic metals such as iron, nickel, and cobalt. These are only pure metals that can be turned into permanent magnets. So substances that can be permanently magnetized are described as being magnetically hard. If these metals have not been turned into a permanent magnet, they will still be attracted to a magnet if placed within a magnetic field. And substances that can only be temporarily magnetized are described as being magnetically soft. So if we're looking at magnetic fields, a magnetic field has two ends called poles, one of which is called the North Pole and one in which is called the South Pole. The North Pole of the magnet attracts the South Pole of a second magnet, while the North Pole of a magnet repels the North Pole of another magnet. A magnet creates an invisible area of magnetism all around it called the magnetic field. So if you cut a bar magnet in half, you will get effectively two smaller magnets, each with their own north and south pole. Magnetic fields can be mapped out using small plotting compasses. So we place the plotting compass near the magnet on a piece of paper. You mark the direction that the compass needle points. Then you move the plotting compass into many different positions around or in the magnetic field, marking the direction that the plotting compass points each time. You can then join the points together to show the field lines, and that will go and show you where the field lies and the extent of that magnetic field. So if a question comes up, describe how to plot a magnetic field pattern on a bar magnet. So same as we've said before, you're using plotting compasses, you're moving them around the magnet, and you are marking on the direction that the compasses are pointing. Magnetic field lines are a visual tool to represent magnetic fields. They describe the direction of a magnetic force on a north monopole at any given point. So we can see from this, the magnetic field lines never cross each other. The closer the lines are together, the stronger the magnetic field. The lines have arrowheads to show the direction of the magnetic field, and the arrowheads always point from the north pole of the magnet to its south pole. So the magnets in a magnetic closure box must not have two north poles facing each other. Explain why. It's simply because two north poles would repel, so therefore the box would not close.
Thanks for watching.